first of all, I don't know how a scientist is supposed to follow that. I'm an academic, and I go to talks all the time, but I've never been sandwiched between a poet, a comedian, and a great chef. And I probably will never be again. It's probably a stroke of genius of scheduling. We'll see how that goes. Well, anyway, one other story before I get to talk about I'm going to give you a very academic conversation here about climate variability and change and its impacts on growing grapes and making wine. However, I do need to tell a little story related to the Mondavis. 40 years ago this summer, my dad took me on a small, I'm going to get emotional over this, I can tell, a very small day trip because I grew up over in Marin County, and we came to Napa, and we stopped on the side of the road to see a gentleman working on his dream, and we stopped, and I remember as a little boy, my dad getting out and talking to Bob Mondavi. I listened, and I ended up playing in the dirt. I remember that very clearly after I got bored. But one of the things that I truly remember about it was the passion of the person. And it carried forward to my family in a big way. My dad is now a winemaker, grape grower, and I do research for this industry. And 40 years ago, I would have never have dreamt that, but through that influence, maybe that brief moment, it was very important in my life. So I appreciate it. So what I'm going to be talking to you about today, again, is a topic that I do an awful lot of research with, and I travel around the world talking about. I'm going to give you a brief outline. It's very academic to do this. I'm going to talk about the science of climate variability and change, what we know, what we don't know. Talk about the influences and risks that are out there in terms of viticulture and wine-related issues. Then look at some observations, clear observations about what has changed, and then look at modeling. Modeling, again, as mentioned, is our hypothesis to the future, and talk about how it looks around the world in different viticulture areas. And then talk about some implications and conclusions, and maybe this will generate some conversation we can have at the end. So just some general ideas. First of all, climate variability and change can be brought about by things that are internal to the Earth system and external to the Earth system. So they're very natural things that are going on. We have internal situations or system structures that are driven by volcanics, ocean snow ice dynamics that are very complicated, but yet we're starting to really get a pretty good handle on how they operate. We also have a series of external influences that are extremely important in terms of driving climate variability and change. Solar variation, meteoroid impacts, and a myriad of other things that can drive our climate. However, one of the things that's coming about here today is that climate change can really, truly be influenced by us. Our planet has a carrying capacity that I'm not sure we know what it is, but with the magnitude of the human impact today, we know that we're bringing about climate change. Some of this comes about through atmospheric composition differences, but I would argue as a climate scientist that we have to look at other things at the Earth's surface that are just as important. Deforestation, urbanization, desertification, all of those issues are just as important as what's happening in the atmosphere itself. When we talk about climate, as climate scientists, we typically study climate from two broad categories. One is empirically based upon observations. I'm mostly a statistician. I punch data all the time, looking at what kind of variability and trend structures exist out there in climate. I also do a little bit of this, modeling. This is a dynamic approach to studying climate based upon our knowledge of the system and building it forward. Climate models are very complex, three-dimensional mathematical representations of our Earth-atmosphere system. And you need to know that climate models are truly hypotheses about the future. We build them based upon what we know, and we drive them forward trying to understand or look into the future to see what we can predict. Other things that you need to know about this is, number one, climate model spatial resolution is fairly coarse. What that means is that we can't predict climate change necessarily in any one vineyard, but we have very good capabilities of predicting what's happening over regional type of scales. You also need to know that climate models don't always get it right. Historically, if you look back in time, even 20 years ago, our climate models were off quite a bit. But there's the big caveat here is as technology and our knowledge of the system get better and better, our climate models are predicting the past very well. We're driving and understanding that past so that we can drive the models into the future to understand what that potential change might be down the road. So now if we look at some of the influences and risks and challenges that are out there in terms of viticulture, there are three very distinct spatial and temporal scales of risk for viticulture and wine production. The very first one is individual weather events. These are the things that we typically are much more concerned with in our vineyards. Things like hail, frost, freeze, heavy rain, individual events that are short-term and localized. We also have climate variability, however. Climate variability is seasonal to decadal on scales and tends to be regionalized, more tied to a given area, and you could have vast differences across a given hemisphere even. Drought, wet periods, warm periods, cold periods, a lot of variation can happen within climate variability. We also have today this aspect of climate change, and this is nothing new. It's been with us forever in Earth's history. Warming, cooling, abrupt changes in moisture. We can have fairly gradual climate change, which is what we're seeing mostly today. However, some people might argue that it's fairly abrupt as well in Earth's climatic history. This is much more long-term, regional to global in scale. One of these scales or temporal influences really either changes or affects another in some very unique ways in terms of what we know. First of all, climate variability changes the frequency of individual weather events. For example, if you go into a very warm period, you typically have much more greater frost freeze kind of characteristics. Even though it's a warmer growing season, you can have the shoulder seasons be still quite cold. You can also have heavier rain events in a wetter period, so that kind of thing we definitely know. We also know that climate change, historically and even today, changes the nature of climate variability. So we have some pretty good connections with that. One of the things that we don't have a very good connection with is this, how climate change influences individual weather events. For example, Hurricane Katrina wasn't caused by climate change, but it was likely influenced by warmer sea surface temperatures that were driven by changes in climate. The connect to one-to-one is really very difficult in the climate science area. So if we take that to the wine spectrum, I borrowed this saying right here from Andy Beckstoffer, that there are 4 ripeness clocks that run simultaneously at different rates for growing grapes and making wine. We know that there's sugar accumulation, acid respiration actually, phenolic ripeness, and fruit character. Kind of a complicated diagram, but what this is trying to show you is what happens from the point of flowering through to harvest in terms of the berry itself. What happens to the berry as it goes through that stage? This is the lag phase right here. Some of you might know of veraison, where you get color change and then sugar accumulation. But more importantly, there's lots of things that happen in here in terms of flavor compound development and a lot of characteristics that go on within the fruit in which we are trying to balance growing this plant, this crop, in the right climate. And we look at this, what happens as the berry goes through its developmental stages and starts taking on sugar, we also know that acidity drops out. And so this is something that we clearly have a lot of information about. We also know that fruit character changes as we go down this spectrum toward a ripening point. We go from vegetal to herbal to fruity to jammy to cooked flavors. So somewhere out here is something that anyone would call the balance zone. We always want to ripen our fruit to produce this balanced structure to make balanced wines. Now, in a given climate, if you've got it right, if you've got the match between the variety and the climate right, you can produce very good balanced wines. In any given year, you can either overshoot this or undershoot it, and then you can have problems on either side. And that's some of the pieces of the research that I've been doing. Putting it in a slightly different perspective, you can put climate varietal thresholds together, looking at wine quality metrics, objective or subjective measures. I was very happy to hear the gentleman earlier say that scoring systems are going by the wayside, but boy, we still need something to be objective about in terms of wine quality metrics. You can also look at climate metrics, any variation of climate, typically temperature-based, in terms of how we know what varietal structure is in terms of climate. The relationship is like this. It makes total sense. It's a parabolic relationship by which we run into a situation that if you're in the wrong climate and or it's too cold of a year, you know you end up with lower sugar levels, unripe flavors, and unbalanced wines. Makes total sense. We also know that when we come to the other end of the spectrum, where it's too warm, either in a given year or you got a cool variety planted in a warmer climate, you can end up with lower retention of acid, overripe flavors, and unbalanced wines. So somewhere in the middle here is this balance or optimum zone where everybody is shooting to ripen their fruit to get consistent sugar levels, ripe flavors, balanced wines. Variations that are driven in there are typically driven by seasonal events, individual weather events that can be problematic in and of themselves. So taking this to the next level and showing you where the connections are with this, we can say broadly that climate influences the style of wine we know that an area can produce. That's pretty clear. I've been doing some research that tries to put bounds on all of this in terms of this threshold issue, looking at what kind of plant growth characteristics and climate relationships are critical for individual varieties. And this is the diagram that is a work in progress for myself. And what this really is climate maturity groupings based upon optimum premium wine quality producing areas related to climate. In this case, average growing season temperatures. Could be any other measure of climate. We could argue that all day, but it all still comes out to say basically the same story. For example, we could say that each variety is typically grown in fairly specific areas relative to that optimum quality and production. We could look at Merlot. We know that Merlot can be grown out over here. It is in the Central Valley of California, but it doesn't produce premium high quality wine. We know that Merlot can be grown over here, but it doesn't typically ripen very well, and so the same story can be told. So we know we have these varietal thresholds that are out there. If you look at some of the historical places in the world, the Mosel Valley, the vertical line here is their long-term average climate. The bars going across with the arrows are the standard deviations of that climate. In the coldest of years in the Mosel Valley, they don't ripen their fruit very well. We know that. That's clear. Climate definitely drives that. If we look at a place like Burgundy, Burgundy is the home for Pinot Noir and Chardonnay because it is centered within that ripening window for those varieties. We can go to Bordeaux. Bordeaux arguably has a problem in the coolest of years. It doesn't ripen Cabernet Sauvignon very well, but in the average to warmest years, it does very good. You go to Napa, a little bit warmer than Bordeaux, and arguably more centered relative to many of the varieties that it's growing. Then you go to a place like Barolo. Barolo is a classic economic, cultural thing that developed over time. They diversified into two varieties, Dolcetto and Nebbiolo. In the coolest of years, Dolcetto-based wines are wonderful. Warmest of years, Nebbiolo-based wines are wonderful. So it's some very interesting ties relative to these locations. So what I want to do is talk about some observed changes. I'm going to go through this very, very quickly because I have some stuff in the Western United States and Europe to talk about. I've done some research for the 50 plus year period over the Western United States grape growing regions. We've seen growing seasons that have warmed 2 degrees Fahrenheit in the Western United States, averaged across all these areas. In Napa alone, the growing season has warmed 3 degrees Fahrenheit, a little bit more than some of the other areas. These are driven by changes in minimum temperatures, not maximum temperatures. This is one of the big disconnects between science and the media and what we understand. We're not seeing a lot of changes in the maximum temperatures, especially in the past 20 years. In some places, yes, but in most places, it's more happening at night. Napa alone is 5 degrees warmer during the growing season at night than it was in the 30s and 40s. Tremendous differences. Decline in the number of days below freezing occurred. It has occurred in all seasons, depending on where you are in the West. You have earlier last spring frost, later first fall frost, longer frost-free period. And by the way, for Napa, 1930s and 40s compared to today, we have a 90-day longer growing season defined by frost today in this region. Tremendous differences. If you look at precipitation, there's really no characteristic changes going on there. If you look at phenology, the plant growth cycles, we're seeing trends ranging from 6 to 20 days earlier over numerous varieties and locations. For Europe, I've been the lead scientist on a study in Europe at numerous locations here, looking at 16 different varieties over a period of time from 1950 to 2004. I'm going to go through this really quickly because it's the same thing as the Western United States. Warming in the growing season, driven by changes in minimum, not maximum temperatures. Decline in frost or freezing scenarios. Earlier last spring frost, later first fall frost, longer frost-free period. It's just the magnitude of the numbers is really the differences. Precipitation really is showing no trends. Phenology. If you look across 16 varieties across these 9 locations in Europe, this is what we're seeing. Bud break 6 days earlier on average to harvest being 17 days earlier on average. If you look at the intervals between growth cycles, they've all shortened. The climate has produced a vine that is accelerated in its growth cycle, and this goes across every variety that we studied. What we did find is that for every 1 degree Fahrenheit of warming, we see about a 3 to 6 day response to the warming. Now, to go from this, and I'm going to go through this real quick as well, from observations to climate model. Remember, climate models are giving us a look into the future, given what we know today. Talk a little bit about the Western United States. This is dividing the Western U.S., Idaho, Washington, Oregon, and California into broad, cool, intermediate, warm, and hot grape-growing climates. White being not viable, it's either too cold or too hot. And if you look at this, this is what we have right now. This is our climate normal for the Western United States. If you go out to 2049, this is what the climate models show. We basically see quite a few things going on. Number one, we see a lot more red that is shifted coastal in California, especially. We see some places in the Central Valley that are less viable. We see some places up in the Pacific Northwest that become more viable in some cases, especially when you look at the cool areas and intermediate areas becoming more viable. So this is out to 2049, given one climate model output. I've also recently done some research where we looked at suitable viticulture zones out to 2100. And if you take the entire United States, this is, for some people might know this, the idea of Winkler regions, the idea of climatically can divide the areas up into their climate suitability for growing grapes. This is what it looks like over the entire United States, blue being cool, red being hot, and you can see the characteristic, especially on the West Coast, the places in which we know grapes can be grown. Out to 2100, if we just look at the changes in suitability, this is what it looks like. Given our current state of the knowledge of the system, by looking at Winkler regions at a 25-kilometer scale, we see that climate changes in the future driven by maximum temperature changes, some minimum temperature changes, but by a lot of maximum temperature changes during the growing season and the ripening period, take that Winkler region idea and reduce it down in terms of its potential to coastal zones and or higher elevations and or more northerly. So we're seeing some displacing of viticulture suitability toward the coast and or northward. Europe, you can see something very similar. It's a colleague of mine at the Potsdam Institute for Climate Change, Manfred Stock, looking at the Western Europe. This right here is a similar index to the Winkler index, but the Europeans, we all know the Europeans like to use something just different than the Americans to say the same thing. So this says the same thing. Going from cool climate varieties to warm climate varieties, and this is in the year 2000. And note what happens out to 2050. Latitudinal shift northward in terms of suitability on the cool side, and then also some places where you end up seeing, viability in these areas here, like Galicia and even in parts of northern Spain, that is being contracted to different areas. And so we're seeing similar kinds of changes in Europe that we do here. And I've done the same kind of research across the world in Australia, New Zealand, Argentina, pretty much everywhere. And the same story pretty much is being told from each one of these areas. So if you take this and you place it in the context of viticulture overall, we go back to this climate diagram, and I'm going to show you three different periods, 25-year periods from 55 to 80, 1980 to 2005, and 2005 to 2030. And we're going to look at these areas, and we're going to start here with the Rhine Valley. We're going to talk about what has happened in the Rhine Valley of late is this. The climates of today are much warmer than they were 25 years ago. And the projected climates out 25 years from now are projected to be as warm as the warmest of years today. And if we know what's happened in the Rhine Valley, we know that declassification of wines is much less common today than it was 25 years ago even. If we go to Burgundy, chaptalization used to be the rule there. Today it's much more of the exception. And if we look at some of the numbers, it tells the same kind of story. The climates of today are much warmer on average, and then the climates of the next 25 years are projected to be as warm as the warmest of them today. Bordeaux is kind of interesting. We've actually seen in Bordeaux in the past 25 years or so more consistent inter-varietal ripening between the right bank, left bank kind of issue, Merlot dominated versus Cabernet Sauvignon dominated wines. And that's basically being told by being in a much more suitable climate. And that may even be spelled more so in the future. We go to Napa today. We have a very long, warm growing season, much warmer than it was 50, 60 years ago, allowing us to ripen to ultra-ripe fruit. Question about balanced wines. If you look at climate structure, this is what the models are telling us for the future out to 2030 for Napa alone. And if you throw that little variability window on it, you could actually look there and say that, well, climates in the future may be at the upper limit of some of those varietal ripening potentials without kind of changes in technology or inputs that we could do to the system. So just some discussion in relative to this, and I think I'm just about on time altogether. First of all, we know that wine production is reasonably, much more so than broad-based crops, climatically sensitive with narrow zones that produce optimum quality. It puts the industry at great risk in general from what we project as our climate change scenarios for the future. We do know that the last 50 years almost universally has been pretty good. We know that there's been longer growing seasons in most places. The marginal production zones, especially on the cool end, have benefited tremendously from longer and warmer growing seasons, less frost and freeze risk, and more consistent ripening climates. However, if we look at the next 50 to 100 years, there's lots of potential issues that are out there. I'm just going to mention some of these things that I think that are very important for us to look at. The idea that phenological timing will be affected in the future just as it has been, and we need to make sure that we look at that and understand what that means for ripening capability. That ripening profiles will likely be very different, and composition differences will be important in the future. Further alterizations in varieties grown and/or regional wine styles. I mean, this clearly has to happen in some way, shape, or form. Maybe not in our lifetimes, but it does have to happen in the future. Spatial changes in viable grape growing regions. Britain's growing grapes again. It hasn't really happened in a big way since the medieval warm period. So we have some definite evidence of that kind of thing going on. Increased presence and intensity of pests and diseases. This is kind of an issue. A lot of people, there was just recently a paper came out on powdery mildew increases due to climate change, and the impacts look pretty intense. We could also say there's added water-related challenges. Even if we can adapt with more irrigation capability, the availability of water is going to be even more important in a warmer world in the future. If we go to some general conclusions, this is something I think is very important. History has shown us that the climates of tomorrow will be different than the climates of today. There's just no doubt. And so can we be static in the things that we do relative to agriculture in general? It's a good question. I truly think that the impacts of climate change are not going to be uniform. I don't use the term global warming because I don't think it's global. We have some very differential impacts that are happening in different places. Glaciers growing in some places, ablating in other places. Temperatures changing in different ways in different places. And so I don't think we're going to have this uniform kind of change. I think what we're going to be seeing is thresholds that will exist in some places more rapidly or sooner than others. Cooler climate regions will always have the greater ability to adapt because they just have a wider range of potential to change. The warmest of climate areas in the world that are growing grapes today will likely have some pretty big challenges. And then 4 words that show up an awful lot relative to climate science and this whole issue of climate change. Urgency. Climate change is slow, it's imperceptible. Hollywood tried to make a movie on climate change, and they didn't do true climate change movie because nobody would go to a slow, imperceptible climate change. They'd had to be extreme. And so, that kind of issue is very important because it plays out not necessarily in our lifetimes, but in the next and the next, and where that looks in our future. Uncertainties. There are a huge number of uncertainties in terms of what we know about the system and where it's taking us. But that doesn't mean that we shouldn't be aware, we shouldn't make prudent kind of changes and understandings about what's going on. In terms of adaptation, I think adaptation is very important. I don't think there's one silver bullet for any industry whatsoever, including the wine industry. I think we'll have to have breeding technology changes for grapevines, vineyard management changes, maybe even wine technology changes that really, we've already seen some of those. But we have to have a portfolio of things I think we'll need to have to adapt. And then lastly, mitigation. A lot of people talk about mitigation being this issue that all of us can mitigate the problem to some degree. It really takes a universal body. Even though individual efforts are good, I think that a global body has to come together to really bring forth mitigation to bring back some real change to what's going on. So I hope that was informative, and I'd be happy to take any questions if we have time.